Hi, my name is David Watson, my student number is 323-52806, and I declare that this narrated presentation is my own work. I picked problem 1 to do my mathematical investigation and exploration on. The problem was to uncover a solution or strategy that Wilma can take, if going first, to leave Fred with just one jelly bean in the jar. Players were only allowed to take from 1 to 5 jelly beans out of the jar at one time, containing 32 at the start. First, I will go through a quick overview of the PowerPoint. There are 6 main points involved in conducting a mathematical investigation, and they are preliminary skirmishing, gestating, exploring systematically, making and testing conjectures, explain and justify, elaboration, and summary. We will look more in depth at these points further on in the presentation. I will also be looking into the strand of mathematics involved in problem 1 and adapt the problem for a Year 5 classroom setting. I have linked some of the points together to cut back on time. The first 3 points we will look at are preliminary skirmishing, gestating, and exploring systematically. In preliminary skirmishing, I interpreted the game. I took trials of the game with a friend and obviously made some simple connections, if there were any. I gestated that going to odd integers will enable you to leave your opponent with 7 jelly beans. This gesture was quickly undone by the fact that your opponent could do the exact same thing, which gave a 50-50 chance of both players being left with only 7 jelly beans in the jar. If 7 jelly beans is the integer you need to leave your opponent with to win, is there a certain amount you can take that will always lead your opponent to 7 jelly beans being left in the jar? This led me to explore the problem systematically, which involves finding patterns from symbols, diagrams, or tables to lead to a sound strategy for Wilma to take. Continuing on from slide 3, exploring systematically, through 3 different trials, it was made clear that from 32 jelly beans, Wilma could use the strategy of getting to the next multiple of 6 plus 1 each turn would lead to Fred ending up with 7 jelly beans left in the jar. Making and testing conjectures. By knowing this strategy works for Wilma with taking from 1 to 5 jelly beans from the jar at one time, I made a conjecture that whatever the maximum number of jelly beans you can take from the jar, if following the strategy of the next multiple of the next integer plus 1 from the amount of jelly beans in the jar, you will always leave your opponent on the last multiple of that integer plus 1, which will lead to your victory. This graph shows that even taking from 1 to 6 jelly beans at a time from 32, the next multiple will be 7 plus 1. To wrap up my investigation, I came to the conclusion that whoever goes first, knowing the correct strategy, will always win. This being getting to the multiple of the next integer after the maximum amount of jelly beans that you can take out of the jar at one time, plus 1, will always lead to your victory. For example, the maximum amount taken out, which is being 6 jelly beans, the next integer being 7, so the strategy is the multiple of 7 plus 1 from whatever amount of jelly beans is in the jar. This is all made evident by following the steps in the investigation and in making connections between data and exploring different scenarios with the same strategy. The strand of mathematics involved in this problem was number and algebra. The current focus is highlighted in blue, with the student being able to identify and describe factors and multiples of whole numbers and use them to solve problems. Investigation for classroom use. I've adapted problem 1 for a Year 5 classroom. and have to take into account the diverse learning abilities of all the students. The higher achieving students should be able to come up with many aspects of the investigation by the end of the lesson. Lower ability students may only come up with one or two aspects of the investigation but feel very satisfactory with the amount of the achievement. Also, needing to talk to students about their problem and understanding what multiples and factors are involved. Data should be collected by students in a table to make connections, and a whole class discussion should take place at the end of the lesson to share ideas and information to classmates.